Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So I obviously want to find the value of x here. So for my solution, I'm going to first start by writing 2 to the power of x is equal to 3 to the power of x. And I'm going to take the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log base a of a, this is simply equal to 1. So as you see here, we have log base 2 of 2. And actually before I cancel these two out, if I have something in the form log base a of to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x as my exponent, so I can move this to the front. So now I have x times log base 2 of 2 is equal to, I'm going to do the same thing over here, log base 2 of 3 to the power of x. I can move x to the front here. So now I have this is equal to x times log base 2 of 3. Now remember, if I have something in the form log base a of a, this is equal to 1. So log base 2 of 2, these two cancel out, so I get simply left with x times 1 is equal to x times log base 2 of 3. And x times 1 is simply x, so I get x is equal to x times log base 2 of 3. Now, I'm going to subtract both sides by x log base 2 of 3. So these two cancel out. I get x minus x times log base 2 of 3 is equal to 0. Now if I factor out x, I get x times 1 minus log base 2 of 3 is equal to 0. And if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and I'm left with x is equal to 0. Alright, so in this problem, I have a to the power of 3 plus a squared equals 36. So to actually find all solutions to this problem, I need to first start by finding one solution. So to do that, I'm just going to plug in some numbers and see if they work. So let's try 1. If we plug in 1, we get 2 is equal to 36, which is wrong. If we plug in 2, we get 8 plus 4, which is 12 equals 36, which is wrong. If we plug in 3, we get 3 to the power of 3, which is 27. 27 plus 3 squared is 9. 36 equals 36. So a equals 3. This is one solution of a. And now that we found one solution of a, we can use this later. So we can use this by making a to the power of 3 plus a squared equal 3 to the power of 3 plus 3 squared, because we know that a equals 3. So I'm just plugging in 3 and making them equal to each other. So now I'm going to subtract 3 to the power of 3 plus 3 squared on both sides. So these two cancel out. I get a to the power of 3 plus a squared minus 3 to the power of 3 plus 3 squared minus 3 squared, sorry. Is equal to 0. Now I can rewrite this to be in the form a minus 3 times a squared plus 3 squared plus a plus 3 is equal to 0. And this simplifies to a minus 3 times a squared plus 12 plus 49, plus 4a is equal to 0. So now this gives me two equations. I have a minus 3 is equal to 0, and I have a squared plus 4a plus 12 is equal to 0. So for a minus 3 equals 0, a obviously equals 3, so this is one solution of a. And for a squared plus 4a plus 12 equals 0, you have to use the quadratic formula to solve this, and I'm not going to waste your time by doing that. But if you do end up using it, you get that there is no solution because you get the square root of negative number. So now that we know that a equals 3, remember how this is actually going to be our only solution because this doesn't work. So a equals 3 is our only solution. Alright, so in this problem, I have a to the power of x is equal to 80. So to solve this, I'm going to first rewrite 80 here as 8 times 10. So now I have a to the power of x is equal to 8 times 10. And now I'm going to divide both sides by 8. So now I have a to the power of x over 8 is equal to 10. So if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1, that's going to equal a to the power of x minus 1, which is equal to 10. Now 8 here is the same thing as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x minus 1 is equal to 10. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1, which is equal to 10. And I can distribute the 3, so I get 2 to the power of 3x minus 3 is equal to 10. Now I'm going to take the log on both sides, so I get log 2 to the power of 3x minus 3 is equal to log 10, and log 10 is equal to 1. So I get 1 is equal to 3x minus 3 times log 2, because I can move this to the front. And now if I divide both sides by log 2, these two cancel out, and I get 3x minus 3 is equal to 1 over log 2. And now I can add 3 on both sides. So I get 3x is equal to 1 over log 2 plus 3. And if I divide both sides by 3, I get x is equal to 1 over 3 log 2 plus 1. Alright, so in this problem I have 2 to the power of x plus x equals 5. So I'm going to first start by subtracting x on both sides. So these two cancel out, and I get 2 to the power of x is equal to 5 minus x. Now, I'm going to divide both sides by 2 to the power of x. So these two cancel out, and I get 1 is equal to 5 minus x over 2 to the power of x. Now, this is the same thing as negative x plus 5 times 2 to the power of negative x. And if I multiply both sides by 2 to the power of 5, I get 1 times 2 to the power of 5 is equal to negative x plus 5 times 2 to the power of negative x. and 2 to the power of 5 is 32, so I get 32 is equal to negative x plus 5 times, sorry, I forgot to multiply this side by 2 to the power of 5, but 2 to the power of negative x plus 2 to the power of 5 is 2 to the power of 5 minus x. Now I have 32 is equal to negative x plus 5 times e to the power of ln of 2 times negative x plus 5. And now it's the same thing as negative x plus 5 times ln 2 e to the power of negative x plus 5 times ln 2 is equal to 32 times ln 2. So I just multiply both sides by ln 2. And now if I take the W Lambert function on both sides, and if you don't know what this is, I highly recommend researching about it. But after that's done, I'm going to be left with negative x is equal to negative 5 plus w of 32 ln 2 over ln 2. And meaning x is equal to 5 minus w of 32 ln 2 over ln 2. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So to solve this, I'm going to divide both sides by x to the power of 2. So then these two cancel out, and I have 1 is equal to x to the power of x over x to the power of 2. Now if I have something from a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2, this is going to equal x to the power of x minus 2. Now if I take the ln of both sides, I get ln of 1 is equal to ln of x to the power of x minus 2. Now if I have something in the form ln a to the power of b, I can move this exponent b to the front, so it's going to equal b times ln a. So now I can move x minus 2 to the front, so now I have ln 1 is equal to x minus 2 times ln of x. And ln of 1 is equal to 0, so I have 0 is equal to x minus 2 times ln x. So now this actually gives me two equations. I have x minus 2 is equal to 0, and I have ln of x is equal to 0. So for x minus 2 equals 0, this is pretty simple. All we have to do is add 2 on both sides, and we get that x is equal to 2. And for ln x equals 0, well, ln of 1 is equal to 0, so x is equal to 1. So my two solutions are x equals 2 and x equals 1. Alright, so in this problem, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So I'm going to first rewrite 9 to the power of x as 3 squared to the power of x, and then rewrite 81 as 3 to the power of 4. Now, this is the same thing as 3 to the power of x to the power of 3 minus 2x is equal to 3 to the power of 4, because 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2x. And now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, x to the power of 3 minus 2x is equal to 4, meaning x to the power of 3 minus 2x minus 4 is equal to 0. So now to solve this, we actually have to find one solution of x so we can use that solution to find the other solutions of x. And we actually have to just keep on plugging in numbers until we find a solution. So if you actually plug in 2, you get that that the solution equals 0. So x equals 2 is one solution of x. And now using this solution, we can find the rest of the solutions by doing long division. X minus 2 equals 0 is a solution. So meaning we have to divide this by our original equation. So we have x to the power of 3 minus 2x minus 4 divided by x minus 2. And if you do this, you end up getting x minus 2 times x squared plus 2x plus 2 is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 2 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. And for x squared plus 2x plus 2 equals 0, I can use the quadratic formula. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a. This is equal to negative 2 plus or minus the square root of negative 4 over 2, which is equal to negative 2 plus or minus 2i over 2, which is equal to negative 1 plus or minus I. So these are my three solutions to this problem.